Hello, good morning. So, as we discussed yesterday, and I'm quoting Vasilis here, building something new with AI is something relatively simple and easy. The real challenge lies in applying AI practices on an existing project, an old one, a legacy one. So this is what I'm going to talk about today, and I'm going to tell you about my team's journey around that. To get acquainted, I'm Ioannis Panselinas. This is how it's pronounced. I'm the data engineering manager with Natech, and I've been working in data engineering for the past 14 years. So, we're building banking systems, so one of our systems has a large database in the back end, and it's about this large. So we're talking about thousands of tables and thousands of pieces of code. Obviously, it's a large one. We've been using SQL database project, which is a special type of project to support Microsoft databases, and we're using DevOps repos as our versioning platform. Onto that database, onto that project, in the past almost 4 years, we had more than 3,000 commits from 58 different people. So obviously, those people do not come from a data engineering background. We are talking about backend developers, we're talking about mobile developers, we're talking about web developers. So they're not necessarily writing the best possible database code. So, big projects, big problems. And this is our biggest one. There are no naming standards in that database. Unfortunately, I don't know why, we have been using Greek names or Greek initials. We've been writing Greeklish for some reason. And this was the biggest thing we had in mind when we were talking about AI, on enabling AI on that project, that it wouldn't be able to understand what we have in our database. And we have been joking a lot about it internally. But also we have a lot of other problems. So we haven't had coding standards, so you could easily identify 58 different writing styles in the database. We have a lot of repeatable code because it was quite difficult to trace what you needed, so it was quite easier to go and create it from scratch. We have no documentation because, let's be honest, if you have a production repo, what do you need the documentation for? And we haven't had any performance optimization on the code we've had. So basically, we're talking about basic stuff. So when we started thinking about how we could integrate AI on that project last year, we placed a barrier on ourselves and said that it wouldn't work. So we didn't really try. We didn't believe in that. So the only AI thing we did was basically Googling. So we were chatting and asking things, generic ones. We've been using the Copilot, for instance, as Google on steroids, instead of searching things over the internet. So we've been working on, we tried a couple of stuff, they didn't work, so we left them as it is. And then earlier this year, something changed. One day, I got this, and this is the actual screenshot I got from a colleague. One of our key tables in that database is called PEM, which means Pelatis Mitro, Master Record of Customers. Don't laugh. So Kostas asked if ChatGPT could understand the reasoning behind that name, and it could. And he sent us that and say, guys, AI could possibly understand our naming standards, so we could work on that. And basically, I started looking for other careers. But anyway, the second thing was this one. It's on late February when Anthropic announced that Claude could understand and modernize the mother of all legacy code, COBOL, and mainframes. So we started taking some small steps. So one rainy morning, because we come from Ioannina, we said, let's create some documentation, because we had nothing. So we provided Opus at the moment with our repo and some examples of the naming standards we have. And we asked, create some documentation and make our repository ready for AI, whatever that might mean. And we got this as an output. We got the structure. Okay, we've been using Copilot, so we got the GitHub folder structure. And we got a number of empty files, like the glossary, the schemas, the relationships, business rules, and dependencies, all from scratch. Obviously, it wasn't perfect, but we adjusted it manually, we iterated, and we got something like that. So if you see here, it has understood all the Greek namings we have. We have some table prefixes, we have some column names, and also some business rules. So what was the impact out of it? Well, we got documentation we had nothing in the past few years. So we could enable other developers as well as onboarding new colleagues from whatever departments. We could also explore the solution now. So you could ask a question and say, how do I find that? And you will get an answer, instead of asking a colleague or instead of searching through the 2,000 tables you have. And also, you could have some simple code generation, basic stuff, but still time-consuming on day-to-day operations. So we iterated, we fixed, we adjusted, and we say, OK, let's move to the next level, which was, let's enhance that. So what we did, we provided the documentation we created previously, the repo, and we asked to identify the core pieces of code we had, procedures and functions. And we got 2 new empty files with the functions and the procedures, the main ones, based on the usage. So it looked like something like that. So we had which functions we use for balances, which functions we use to get customer details, the key functions that everybody should use to create new code. So what is the impact, again, out of it? We could have some complex code generation. So we're adding functions and procedures in the loop. So basically, we can do more stuff. But, let me go back, sorry. The code that was generated was not that good. It could get the same result, but it was not optimal. For anyone that could understand SQL, you can see that there are many outer applies. If I wrote it, I would write it differently. So the next step was to add some rules in the generation of the code. Again, we had no material. So what we did was this one. We had enabled some static code analyzers on the project. So a rule-based engine that goes through your code and identifies issue. For instance, if a table does not have a primary key, some basic stuff. So we had that rules, we had the results, and we also had a textbook with some guidelines, basic ones. So we fed that to AI, and we asked, create some development guidelines. And we got another empty file, which looked like that. So we got a set of rules for tables, for temporary tables, pretty much guidelines on how you should create code. And we didn't write anything by hand. So what does the impact? We could start generating some performant code that would look more like to what we as developers would develop. We could also review our code in real time. So whenever someone created a new piece of code, he could, with a simple prompt, check if this code is compliant with our best practices. So as you see, you get the result, and you say, this piece of code has these issues, so you should fix them before proceeding. And it could also do it. So you could simply say, fix whatever lies in this piece of code, and it would do. It would change things to make it more compliant. Using that, I recently had a junior engineer making hundreds of edits on tenths of objects within a couple of days, things that we wouldn't do otherwise. So the next step was to start deploying, provided that we set the ADO MCP correctly, and we had the previous input, the repo, the documentation, and this is an interesting piece because I wouldn't expect I would get something out of it. We had an internal meeting with the team discussing about how deployments go, what's the process, what it does. We're using Azure pipelines. So we took the transcript of the internal meeting with the team, which was in Greek, fed it to AI, and with the documentation, we got a deployment MD that describes all the steps, all the parameters we use, all the agent pools we have, everything that somebody should know in order to deploy anything. So, what was the impact out of it? We could deploy with a simple command. So, I could open a branch, say deploy it to that server, and it would push it and initiate the deployment pipeline. As simple as that. The screenshot is the actual screenshot of the deployment of the command I ran. We could also have more complex tasks. For instance, we could ask to create a new feature branch, fix something, push it, and run the build pipeline to check it. And you would simply go in the Azure portal and see what was the output. That's it. So, we also have a couple of things that we're trying to work at the moment, continuing this work. So, we're working to performance tuning, which is, at least for me, a huge subject in databases, because there are no really handbook to do that. So, we'll probably end up with another MD file, and we will be saying, fix performance-wise this code, and we'll expect some re-engineering. Despite the fact that I hate the term, we're coding a data quality tool. So when we ship the database to a customer, we could also run some data quality rules to check the integrity of the data. 10 years ago, the only option you would have would be to go and purchase something from the market, which would cost several thousand. And we're also vibe coding another tool. So obviously, on top of that database lies a lot of services exposing a number of APIs. So if you want to run business scenarios, you need to trigger a lot of those APIs. For instance, create a customer, create an account, deposit some amounts, do things like that. So we're creating a workflow tool that could chain all those API calls into an end-to-end workflow just to simulate business scenarios. So, and I think I went too fast. The conclusion out of it is that when we started, we just had a database and nothing on it. That's it. And now, we do have a database and many other possibilities around it. We could fix things, we could review things, we could enable other developers. That transition happened fast. And regardless of what I put in my timesheets, it took a couple of days to do that. And the real benefit is the below. We can respond to bugs and tick issues and new development more rapidly. We have enabled all the organization to use that repo, and regardless of the level of expertise in data, he could do the work as efficient as a more senior member. And the last bullet, and the most important to me and to my team, is that we have unlocked re-engineering. So pieces of code, areas that we know that need re-engineering, but it felt too much of an effort to do, so we just kept them as it is, are now open, and the scale of cost versus benefit leans toward benefit because we can automate things. So we have enabled our team internally and the other developers in the organization. So what I would try to leave you with, closing the presentation, is that, first of all, we might think in many cases that AI will not be applicable in our project, in our repo, in our solution. I don't think that this is the case anymore. We don't have that strict barriers on what is legacy and what is not. And secondly, that whatever piece of information you have around your projects, around your repos, could be an asset for AI. So you could use it to do something to go further. And that's pretty much it.